You want to become an AI engineer, but you're staring at a mountain of skills: Python, PyTorch, LLMs, RAG, linear algebra, and you have no idea where to start. You're worried that it's too late or that you're not smart enough. I've been there. I literally stared at Python errors for hours feeling like an idiot. But today, I'm cutting through the noise. I'm giving you the complete 2026 roadmap. From your first line of code to your first six-figure offer. Let's get started. One of the first thoughts that might come to your head is software engineering or tech, is that career dead? Mainly when you go on, let's say LinkedIn, for example, you see more and more layoffs or hear it in the news, or that AI is able to code right now. It's not dead, it's just different because now the era of like tutorials, just copying and pasting of code, going like on YouTube, seeing someone code something and pasting it and then putting out your portfolio, that era is over. And I could say that because a year ago, I had people approach me saying they're really interested in coding and they wanted to learn, and met up with them this year and asked if they're not interested in coding anymore because they want to understand AI. And the thing is about that is that it's no longer the actual code of copying, pasting, or just being able to code itself because AI can code for you. It's more of a builder mindset that is required. Being able to build a system and apply these models or these codes and apply it specifically to real world problems that companies face that they want to solve. So there's so many LLMs out there, large language models, right? But right now it's generic to the general public. Companies see the power of it. They want that the LLM power, but they want to apply it to their problems, to their data, to their company. Like for example, their data usually in a lot of companies, it doesn't even have to be an AI company. But in fact, most companies want to use AI are not AI companies or even tech companies, but they have data that lives all over the place over the years, in emails, in documents, in maybe a Confluence page or however they do their documentation. And they want to consolidate all that and be able to have access to it and use LLMs to query about them and give them insight. If you're able to chain all that together and actually solve their specific real problems for their company, that is extremely useful to them. One advice I would say is be wary of anything that says, okay, learn AI in 30 days. The reason why I say that, because for me, realistically, it took about 3 or 4 months to start learning the foundational stuff. Like first you have to learn just the language in general. Right now, Python is the actual language of choice for AI, not because it's the best, it's just that every paper uses that by default. You can actually do AI and build models, model architectures, neural networks out of any language. But if you're going to read a paper or try to implement something and they use Python or use another language, you have to do that extra step of knowing both language well enough to convert it, as opposed to just using what they already use, right? Just reduce the friction, just learn what they're using right now. And then after you learn the basics of that language, then you have to know the tech stack, exactly which part of it they're using. For example, they're using NumPy. There's also Pandas. That's another one you want to know. And then there's also Matplotlib. That is to visualize. These are like the basics you should learn in general how they work, because that is used all the time. These are more like data science techniques as well. And then you want to start getting into specifically the framework they use, like PyTorch. That is used, spell that out here, PyTorch, that is used to actually build actual neural networks and train the models of that. Once you know that, that's about 3 or 4 months. At that point, you know enough of the foundation to understand. Of course, you're not a master of it, but at least from that point on, you can start applying for jobs, because it takes time before they actually reply back to you. And during that time, you're actually building out real world problems or real world solutions to problems that the companies you're applying to might be interested in solving to prove out your portfolio. So realistically, it takes about 6 to 9 months, like around 3 to 4 months before you know enough foundation to reach out to people. And then it takes people don't reply to you right away. And it's a number game. It's a numbers game. So you put things out there, then after a while, they're going to get back to you. So, and while you're doing that, you're building out your portfolio. So it takes about 6 to 9 months of meaningful work before you start seeing any traction. And that's about 20 hours per week. And that may sound like a lot, but if you think about it, that's about 2 hours a day during the weekdays from Monday to Friday. People sit down and watch Netflix and binge it without even realizing that. If you actually put something towards your career that could actually better your quality of life, that for only about 6 to 9 months, that could be a much better return on your investment, right? And another reason why I say be wary of 30 days, because this is a marathon, not necessarily a sprint, right? You want to have enough foundational knowledge to understand what's happening and then building out your portfolio to build real problems. So by time this 6 and 9 month period comes around and people are applying to you, you actually have something meaningful to show. Phase 1 of the roadmap, learn the foundation. So what is that? I would say learn web development first, which actually includes Python part of it. That's actually would be part of web development, usually in the back end of it as well. And that also links with the actual frameworks or the language that's used for machine learning or AI. That's papers like PyTorch and all that stuff. So it's actually very helpful to know Python. So the thing is, why would I suggest use web development before I start learning all the math? One, for me, was to avoid burnout early because web development's been around for a while. It's pretty well known. It's pretty universal. As long as you have a computer, an internet, and a web browser, you can do web development. So you can actually get quick wins and avoid burnout, because when you start doing the math like calculus statistics and linear algebra and start dealing with the matrices, and then on top of that, learning the languages to manipulate those data, you're going to get burnout fast, I would say, for a lot of people when you start out, because, especially if math is not your strong point, because you have to learn a lot before, and it's very cryptic as well, before you actually can do anything. Whereas with web development, you see results right away, right? The other reason why web development is very important is because it's probably the most universal way or software or pipeline that works with everything. So because in a lot of cases, at least even when I do prototypes, even if the final platform is not web-based, AI usually lives on servers when you start it out. So you could build one server where it's like on a computer that's powerful enough to run the models, right? And then build an API to deploy it and have anyone access that server. And you don't necessarily have to have a data center. In fact, most of the time it's not a data center. You can build it on your laptop and then test it out why all the other computers could log into that, or basically use an API to get access to make it work. And then you can scale that up to data centers. So basically that's the most universal way to make it interface that everyone knows how it works. And you can easily build web apps for it. But even if you are, the final product might be, let's say, a mobile device, look on the mobile device, usually the prototype will still be on here because you get all the functionalities. It even do web apps, which is basically a website that acts like an application that can even compile it to a mobile application, but it's really just a website, and all this stuff will work before you're doing proprietary hardware and whatnot. And that's more specific to your use case. Let's say you're doing a video game and the model has to work inside the game. Once you prove that it works out in here, then you can convert it. But web development is the most universal way, and a lot of times that is kind of like the end result as well. And the other thing is just learning the internet plumbing, because just like how Python is kind of like the de facto, the internet plumbing, you could see this pretty much all the time. How does HTTP work? What is JSON? How do you send packets of data across client server, right? The server or might, the backend might actually have the model being processed on a more powerful computer, and then the clients are all the other computers, maybe your mobile phone, who are accessing it through the website. Understanding how that works is going to be pretty much the same way everywhere else. Even if you do it on another platform, the idea might change a little in terms of the actual implementation, but the strategies will be the same. Of we need something that's actually processing it. We need someone interfacing, that someone's actually accessing to it, and like there's someone actually using an interface that's calling the back end, and then the data has to transfer. Even if it's not the web internet, that concept is still going to be there. And the other thing is, when you start off, just build out tiny web projects. And one thing I actually thought of recently is that a lot of times you want to think of more systems engineering instead of building out an entire monolithic application. You want to think of what are the small subsystems that this application have to do, and build tiny projects just to do that subsystem. Like, for example, let's say this program, this app needs to take a lot of files and then rename them, right? That might be part of your application, a larger application, but your project might be just to do that, take a lot of files, rename project. That's it. Now, the thing is, it might be ugly, but it's functional. And when you do tiny projects, once you solve that tiny projects could be used over and over again for a lot of bigger projects. Whereas if you made one big monolithic project, you can't really pull that out and put it in another project. So doing a lot of tiny projects, link them together, actually makes a bigger project. And that is actually what system design is. That actually is a better way of thinking, breaking them down into smaller projects. And again, learning the Python fundamentals only, I would say, because Python is a general scripting and programming language, super powerful, but it could go into so many different domains. And if you're using it in machine learning or if you could use it for web, it's going to be different if you're going to use it in the context of, let's say, making a video game and other applications. There's so many ways to go. So if you were to go in and start learning Python in general and just learn that, you could go down a rabbit hole and become a master at Python, but not specific to the domain you're trying to solve. So what I would suggest is learn the fundamentals of Python, like of coding, basically. What are variable, loops, functions, just the basics at the start, and then start doing tiny scripts and building out small projects with just those basics. And at the end, that's going to give you enough information to know like the next phases, the higher level stuff that is specific for AI. And also just general idea of like automation and building, the intuition of how you build things, and basically things that you would actually do for web development. That will be enough to understand just the basic stuff of how data would flow and transfer between client and server. Phase 2 of the roadmap is actually choosing your lane. So what I mean by that, right now in 2026, the term data scientist, that term is too vague. That's like saying I'm a doctor. Well, what kind of doctor are you? Are you a brain surgeon? Are you a general practitioner? They're different, right? I would say there are 3 distinct career lanes right now. So the first one is the analytics lane. That is pretty much like SQL, having dashboards, business intelligence, and you're basically analyzing information and presenting it to the executives or the leadership so they can make decisions, right? Now it's pretty good, but there's pretty much a ceiling to that, right? Now there's not really much room to go beyond that. The second lane I would say would be the research lane, right? I would skip this one in this video mainly because this is more now PhD, master's, PhD level theory. So you have to be really strong at math in terms of calculus, statistics, linear algebra, understand the papers, understand the state of the art, be able to push that forward and build that out. You're really interested in actually building the models itself. And now I'm not going to get into that because mainly what I want to talk about in this case is actually applied AI engineering, because the research lane, you're like building for the future and it's theoretical. You're basically in academia, you're trying to show the state of the art. These are the values according to whatever metric they have, and we got better values in our experience. So our method is better. Not necessarily proving that this solves a real world problem. Whereas applied AI engineering, I'd say it's a sweet spot for a career for most people, mainly because you're an engineer first and AI is second. You're basically a software engineer, it's just that you happen to use AI models, so you're an AI engineer. But why is it a sweet spot? Because companies are actively seeking people to solve the problem. And if you could solve a company's problem, they're willing to pay a lot of money, especially if you could do it and it's a real pain point that it's super valuable for them to get it solved, right? And a researcher, they might know AI, but if they can't actually apply it, they're not as useful to companies. So this is where becoming an applied AI engineer is really important, and you don't have to have a PhD to do that. If you could prove that you could solve a company's problem and you're valuable to them, you are important. And again, important people get what they want. Phase 3 of the roadmap is the data stack. And this is actually the boring stuff, but this is also like 80% of the work here. And the main thing is it's actually dealing with real world data. And you'll find out, and I could definitely say this for a fact, I've seen companies, especially years ago when AI and machine learning was the big thing and every company wanted to use it, and they contracted companies out to build AI models for them. And they found out most of the time they couldn't work with it because the models they were creating were built off of like perfectly curated and processed data with no mistakes, and it's useful for the model. You just put it in and everything works. The real world, you have missing data, it's broken, it's inconsistent, they're all over the place because some information might be in emails, some information might actually be physical papers that they have in file cabinets that they store for the last 7 years in an attic somewhere or in a storage area somewhere. So, and some things where like their POS or the point of sale system. And one of the biggest things, for example, is the date. Dates are not the date is not on the calendar, is not standardized worldwide. Some of them might be day, month, year. Some is month, day, year. Some of them might put the 4 digits for the year, like 2026. Some of them might just put 26. So if you take the raw data and put it in a model, it's not going to work. So you have to learn the basics of pandas and like NumPy and be able to take like an Excel sheet or a CSV, which is a comma separated value, like kind of a text version of like an Excel sheet, put into pandas to process it using the numbers, the numerical power of NumPy to actually process this data, but also to clean it to say like what to do if there's missing data, what to do if the dates are in this format, or basically take them, mark them, and reformat them so they're all consistent. How do you even curate the data? Like if all the data is in a file cabinet, you might have to go to the company and say, hey, let's hire, let's export out a team or hire a team to go in and scan all the data and digitize them and then put it in there. And then you could go in and then do the cleaning of the data, right? The main thing is, if you want to practice, you have to practice with real world conditions. So you want to practice on real dirty data sets. Maybe when you're learning at first, to learn how the process works, you might be using clean data sets that you could get off of the internet, like on Kaggle, for example. But that is to learn the process of how to use some of the tech stack. But to do it in the real world, you're going to have to work under the worst conditions. That's where your value comes in, because when companies hire someone who knows AI, claims they know AI, and they go in and they're like, oh, well, I can't work with this data, and then they don't get the job, right? That's where you come in. That's just where your value comes in, right? So really avoid curated examples, right? Use real world data to figure it out. So you have to learn like SQL fundamentals. A lot of these things are done in like Pandas or even in Excel or Google Sheets. So learning like SQL and these, like how to select, join, group by, these are very important. Phase 4 of the roadmap is machine learning and math. That's now where you're actually getting more into the specifics instead of just learning Python in general and just learning the data science stack of like NumPy, Pandas, Matplotlib, things like that. Now we actually start using machine learning. Now, one thing about it that you might be asking, well, do I have to be an expert in math? Well, you have to know enough of the math to get by. You don't have to be like a math expert and understand every single proof and know every single paper and have graduate level ability of it. What I would say, you do just-in-time math learning, mainly because you'll notice that they only use a certain subset of each thing of, like, say, calculus. Like you want to learn gradients, you might want to know derivatives, understand just fat parts. You could understand in general what's that doing. Then in statistics, there's also certain concepts in statistics you're using. Let's say like linear regression. What is regression in general? That concept will port over. And then also linear algebra as well, where you're basically taking matrices or just a bunch of numbers, multiplying with another bunch of numbers, for example, and getting a result. Once you know just a few of those things and understand how it works, then that you can pretty much get by, because as an AI engineer, you're not going to be building the models unless you want to be a researcher and do PhD. You're going to be using them, right? You just need to understand enough of it to understand what the values mean and how to connect them, and you can go on. So I would avoid front loading a lot of theory, like going on and try to get a math degree. You just need to know just enough. When you encounter something, look it up to understand what it is and move on, right? And again, what I mean by that, I learn math from errors. So I keep going until I run into an error, and I'm like, okay, why is it not working? Like, for example, if you're using NumPy, the theory itself will be, let's say you're multiplying matrices. So that's the mathematical part. Then I'm going to apply it in NumPy, and they're like, okay, well, it's not working, and the error is giving me the dimensions are not matching. What does that mean? Then I'll look it up, understand enough of linear algebra and NumPy to understand what that even means, what are dimensions. Oh, you have to reshape it. What does reshaping mean? If you have, let's say, in this case, let's say you have numbers that are in a row like this. So you have 2 rows, and let's say here, and here's 4 columns, right? Well, they might be say like, hey, in this case, we want all the same data, but reshape it to be all in just 1 row, 8 columns, right? So you're like, okay, if you don't do it in this method, then it can't calculate to each other. Like you'll understand, okay, that's a mathematical construct, plus how do you do that in NumPy or the code? You start encountering that. At first it's really annoying, but once and it might take you a long time to figure it out. But once you figure out, you start seeing the same type of things, and you'll get it, right? And yeah, again, the linear algebra intuition, pretty much learn vectors and matrices. That is most of the case what you need it for. Just understand that. Calculus, I mentioned before, mainly just like the gradients. What is pretty much derivatives. Just understand that you don't necessarily need to prove, the proofs of it. You're not going to be on a test where you have to go and read out a whole paper proving it. Just understand how it works and what it's meant for. And again, I would say learn the classical machine learning first, like what is regression, what is classification, before you start learning the new advanced. Every week there's a new paper, a new technique, right? One thing, if you want to learn machine learning in general, Andrew Ng's ML specialization, that is really, really helpful it's like an industry foundation to understand it. Though there's a lot of math and stuff that's explained in there, but it's really, really helpful in that case. Up until 2026, which is now, we would be done with the phases that I mentioned before, but now we have phase 5 for modern AI. You have to take this in consideration, especially LLMs and RAG. So modern AI, this stuff is mandatory. You have to be able to build with large language models, not just be able to prompt typing into like ChatGPT. You have to be able to build with them in your actual frameworks here. So again, it's software engineering, but now you're including AI part of it. So that's what makes it AI engineering. So you have to think API first as a mindset. So how to use Python to chain everything together and bring in LLMs into your actual framework to make it work. Not just prompting, actually have it integrated with it to actually solve the problems that prior you couldn't have done it before or much more difficult. So the other thing as well is that at the end, you want structured output with reliable responses, because one of the things about large language models is that if you go in and ask a question, it'll give you an answer. But then if you ask the same question, say the exact same wording, it can tell you the general same answer in general, but the words would be different, or how they present it or how they structure would be different. So one thing you have to be able to account for that is how do you make it consistent, at least formatted in a way that the output is actually useful and predictable, so you could put it into the rest of your systems in your design. So the other thing is the RAG fundamentals nowadays, which is a game changer, and this is what makes it very possible to be used by companies, because when, let's say, ChatGPT came out, yes, there's a lot of LLMs now, but I'll just use ChatGPT as an example. It was very helpful. Companies started using it, and first they started seeing, okay, well, one, the answers are generic. It's not specific to what my company needs or my company data, right? It's not aware of our domain. And two, when it doesn't know the answer, you don't know that it doesn't know the answer because it starts hallucinating and start making things up. Now, RAG, which stands for Retrieval Augmented Generation, that solved that problem, because now you could actually train it with company's specific data. So when it's looking it up, it won't make it up because you actually have the information. So think about it as you have the brain plus the memory when you start using RAG. So how you can think about this is like, how do you connect the brain, which is pretty much like, like ChatGPT, let's say 4 or 5 now or whatever that's out, right, to the memory. And that is basically that the memory is like the company's private data, right? Like what's it found in their PDFs, what are found on their emails or whatnot. So the information's there, but it could actually be processed in a way the LLM could actually process it, right? Now, how could you actually practice this as a real example that you could use in your portfolio to showcase to companies so they'll hire you? Well, when you make your portfolio or your resume in PDF, you can make a PDF chatbot that basically you build a chatbot that is able to answer your questions about your resume itself. So that will be a very strong portfolio piece because it actually demonstrates that you're using like an LLM, something that the recruiter, whoever, can actually interact with, ask questions, but it's using kind of like the RAG format or RAG approach over here, where the memory itself is actually your resume. So it's actually specific to what's on your resume and not generally just generic like ChatGPT answers, and that will start hallucinating, making up things that sounds like they're correct, but when you actually read the resume, is not correct at all. For phase 6 of the roadmap, building experience when no one will hire you. So let's face it, when you start out, you have actually no experience at all. So that's the problem. How are you going to hire you? Because they want someone to solve the problem. Think about it. If you have you have a house right now, and now you have a leak, and the pipes burst, and there's water floating everywhere, flooding everywhere. If you want that problem solved, that's when you're going to look up and I'm going to find a plumber, and I need the problem solved right now. You didn't think about a plumber until you had a problem. So what you're going to do is going to look up a plumber, and you want someone who's done this before, have experience, and can solve that specific problem. You're not going to hire someone, at least ideally, you wouldn't want to hire someone that had no experience at all. So if you look at it from a company's point of view, that's the same thing. They're going to look at, you're going to go and ask for a job or request a job, but the company is not just making jobs for no reason, is they have a specific problem they need to solve now, and they're trying to find the best person to solve it. And if you have no experience and no proof of it, they're going to look over you. So what you want to do is create your own experience, right? And one of the things that really helps is, I mentioned this multiple times before, but your domain experience is your advantage, because you can leverage your past career because you know what the problems are, you know the things that annoy you, or the pain points that could expedite if you knew AI, or how to make the process a lot better. And if you know that domain experience, that will make you a lot more favorable to be chosen than someone else who doesn't know that domain. For example, let's say you're an accountant and now you're trying to pivot into AI. Instead of making like generic projects where you're like, okay, like you'll find on YouTube or something like that, cat versus dog image compare, right? Like it's going to figure out which one is a cat or which one is a dog. For some reason, every project uses cats or dogs because there's so many on the internet for that, right? That's not useful to a company that is like an accounting company that they don't deal with cats or dogs or try to figure out which one, try to identify which one is in a picture. What would actually be useful to them in this case might be an invoice parser, where they have to manually do data entry, go through everything in their invoices. Maybe they physically do it on paper. A lot of companies are not digital right now. They've been around for years, and they've done things as the old way. And I can tell you for a fact, I know a lot of people who are doing this right now. You could make a project where you go you could make a pipeline where you take a picture from your phone, it could digitize that, then use AI to parse information in there and actually give out digitize it and put it into an Excel sheet or whatever format they're using, so they can save them hours of work and going through all these things, right? That solves a real world problem. And if you could link a business case to it, how much value it'd save for them, they're actually going to be interested in that, especially if you know that domain, because they'll give you other problems and pay points for you to solve, right? So you want to build niche AI tools that's industry specific to the value, because those are the pain points they face with, so they see the instant value of it, right? And the other strategy, which I actually do a lot when I start out, is I do free work but strategically, right? I choose real clients that have a problem and I say, hey, I can do this work for free for you. I'll build it out. All I need at the end is that, obviously you have to do a good job and get it to work, is that you want their testimonial for it, if they want a reference point for it, or also you could actually put down on your resume that you actually consulted for that and solved a real problem. So ideally you want to do something that's in the industry you want to actually work in. So when you go in and actually apply for a job at a company, you actually can show real world experience from it. So yes, at first you might not be paid for that job, but the benefit from that outweighs it, because one, you get experience with relatively low, I guess, friction or risk, in the sense if you don't do everything perfectly, your client probably won't mind as much because it's free in the first place. And the worst that could happen for them is that they're just at the same status quo. Nothing's changed. They didn't lose any money. The problem's still there, but it was there before. But the best case scenario is that you solve the problem, they're happy, they'll recommend you, and you actually have real world experience. You know how it actually works in the real world and how to actually solve the problem. So consultant identity shift, when you start off with that, in fact, this might be so helpful that you might have word of mouth that they could just keep giving you other jobs, and that is actually a viable thing. In fact, could even possibly pay even more. But of course, that is another avenue you have to do in, because you have to go find a bunch of clients and keep that going. But that can help you definitely get into bigger companies, because you actually delivered a real product for them. Phase 7, the interview strategy. So normally a lot of these tech companies have 3 interview rounds. You start off with the recruiter, then the technical, that's the coding interview, and then the on-site behavioral interview where you actually go in and they meet you and whatnot. And if you're more senior, that's when you start doing system design. And one thing I would like to say about these interviews is that it's a ranking system, so you really want to study for this, especially if you start getting into the system design. It makes salary a big difference. You could go from ranging from $500,000 to $1 million once you get to the higher round. So you want to take these interviews seriously. This is why it's like studying for the SATs. You want to make sure you know what you're doing when you get in there, right? So let's talk about each one. Usually the first round, the recruiter, that's where you come and you talk to them. You give them your story, like from your past and how you got into AI and transition and why you want to do that. And usually a lot of that is they're just looking for a lot of keywords because depending what it is, they might know a little bit of certain things they're looking for that you have to make sure you can pass to the next level, right? So it's mainly just make sure you have that in place. Now then, technical screening, that is really important. This is what you want to study for. And typically, even senior people, no matter how skilled you are as a programmer, as an AI engineer, or machine learning and whatnot, you want to study for this because it's like a performance. It's kind of like if you're studying for the SATs. Under normal circumstances, you don't know these things off the top of your head, but it affects your salary, it affects you if you get the job, and which level of salary you have, and which level you start off with, and that greatly affects your quality of life, right? Yeah, there's a big difference between $500,000 salary and $1 million salary, depending on your performance. Again, depending on what type of jobs you're looking for, but these are kind of like ranking systems, right? So you want to study for this, and people usually take like 6 weeks, 2-3 months to practice. So when you get there, you know what the problem is, you know how to talk through it, you know how to explain it in the terms of that they're looking for, like the big O, like in terms of time complexity and space complexity and why you made certain decisions and what they're looking for and clarifying. Because this is what you're going to be doing on a team. You want to make sure you understand what you're doing, you're able to communicate, you're able to clarify information and get to the end result within a certain time period under a certain level of pressure. That's why you want to practice for this stuff, right? And once you pass that, then you go on to the on-site behavioral interview. And the other one, again, if you're more senior, you want to start talking about looking into like system design thinking. So this is more higher level. How would you approach solving a problem on a much bigger scale, given the constraints of the reality and how you go about that in a practical way, right? So that, again, this is more when you're more senior of this, but again, even if you are more junior coming into this, system design is super important. It's what actually makes things more efficient or even work at all. So you should be incorporating that even in earlier stages in your career. It'll make you actually a much better engineer, problem solver, more valuable to the company. And again, if you're valuable and important people get what you want, which means you have a better quality of life, right? And the thing is, when you do get the job, the first job reality, like with most people, you probably have imposter syndrome, right? That is normal because you're in a new environment. You don't know how it works. You're trying to, get the lay of the land, right? What I would suggest for that is you deal with just the boring discipline that like make sure you have the fundamentals down. You know how to use Git for source control, Git flow of how to work on a team and work on the same code base. You know how to make tests, like test-driven development, like TDD. So how do you actually make your unit test to make sure it fails if you don't have it implemented, and how to solve that, how to fix those problems. A lot of these basic things, you want to make sure you have those fundamentals down. Then you're going to learn more specific of the actual project itself, and every company is going to be different, so you're going to have to learn their lingo, their language, and the problem you're solving. But then that's another challenge. But by then you're in there, and you should be well prepared with what you have with this roadmap in terms of understanding the fundamentals of the coding that you need to know, then the data stack, the data science stack, to make sure you know how to clean data, basically the basic levels of data science, because most of the job's going to be with that. Then know the frameworks for ML and AI, and then actually apply into a real world scenario so you can actually give business value.